Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 2 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 135, candy. So let's read the problem statement first. There are n children standing in a line. Each child is assigned a rating value given in the integer array ratings. Okay, so see this example number 1. So ratings is given to us, right? So this is a rating for child 0, let's say. This is a rating for child 1. This is a rating for child 2. Okay, you are giving candies to these children subjected to the following requirements. First condition is each child must have at least one candy. Okay, so we have to give at least one candy to all the children. Okay, so initially let's say this child has one candy, this child has one candy, this child has one candy. All right, next condition is children with a higher rating get more candies than their neighbors. All right, so children with a higher rating. All right, so here in this example number 1, if you see, this is a child 0. Okay, this is child 1 and this is child 2, right? This is child 2. Okay, so here for this child, if you see, for this child, okay, so candy initially I am giving just one candy to all the children, right? So for this child, if you see in the left side, so there is no rating, right? But if you see in the right of this, the rating is 0, right? So this child's, okay, this child 0's rating is greater than the child 1's rating, right? So children with the higher rating get more candies than their neighbors, right? So here, why I'm giving just one candy to this child 0? Okay, so let's make it 1 plus 2. Okay, so we have to give larger than this, right? Right, so children with the higher rating get more candies than their neighbor. Okay, and we have to also make sure that we have to return the minimum number of candies, so you need to have to distribute the candies to the children. Okay, all right, so this is done. Okay, so now see, this is good, right? So here I'm giving 2 candies to this, right? And for this child, if you see now, okay, this child, so in the left side the child rating is 1. Okay, so I'm good, right? I don't need to give more candies to this one then. All right, and in the right side also you see, this child rating is more than this one. Okay, so there is no impact, right? So I don't need to increase. Now if you see this, for this particular child, okay, so in its left, the child rating is 0, right? So this child is having higher rating than this child, right? So what we need to do, so here it is getting one candy and it is also getting one candy, so this is wrong, right? So children with the higher rating get more candies than their neighbors, right? So here if it is getting 1, so let's give it to 1 plus 1. Okay, this is one value is 1 plus 1. Okay, one more candy, so I will make it 2. All right, so here this is good, right? Now for this 2 in the right side there is no other children, so we don't need to check. Okay, so in the end, if you see here, we are giving 2 candies to this child, 1 candy to this child and 2 candies to this child. Okay, so 2 plus 1 plus 2 is equal to 5, right? So you can allocate to the first, second and third child with 2, 1, 2 candies respectively, right? So problem statement is actually very easy, right? So what you are doing, you are giving the candies to these children subjected to the following requirements. Each child must have at least one candy first, and the children with the higher rating get more candies than their neighbors. Okay, all right, so this is what we need to do, right? So let's see if we can implement the same approach here. Okay, so here these are the ratings, right? So this is, let's say, child 0, child 1, child 2, right? So let's pick this child first. Okay, so first we are going to give one candies to all the children, right? One. Okay, so this is first condition, right? Each child must have at least one candy, right? All right, so now after that, see this. So this child, okay, C0, this child, in its left there is no children, right? There is no other child, right? And now check the right of this. All right, so in the right, child 0 has less rating than child 1. Okay, so we are good, no issue. Let's give just one candy. Now see this. Okay, child 1, so in child 1, the rating is 2, but in the left side, okay, this is a neighbor, right? Child 0, he is having a rating just 1. Okay, so this child 1's rating is greater than the ratings of child 0. Okay, so why I'm giving just one candy to him then, right? So children with the higher rating get more candies than their neighbors. Okay, so let's do one thing here. This child 0 is getting just one candy, so just here for this child 1, just add 1 to this. Okay, so child 0 getting one candy, in this one add 1, so let's change it to 2. All right, so this is done. Okay, all right, I'm good. Now same way check child 2 as well. Okay, so rating of child 1, tell me if it is greater than the rating of child 2. No, okay, it's equal, so no need to do anything, right? Now let's move to this child C2. Okay, for this C2, if you see in the left side, rating is same, right? So no need to change, right? In the right side there is no children, right? There is no other child, so that's it. Okay, so we have to stop here. So in the end, 1 to 1. Okay, so total is 4. Okay, total 4 candies, so you can allocate to the first, second, and the third child with 1 to 1 candies respectively. The third child gets 1 candy because it satisfies the above two conditions. All right, so this approach is working fine here, okay, in this example number 1 and example number 2, right? But now let's see if this same approach works fine in this particular example. Okay, so initially this is child 0, okay, child 0, child 1, child 2, child 3, child 4, and child 5. Okay, so initially we are just going to distribute 1 candies to all the children. Okay, 1 1 1 1 1 and 1. All right, so this is done. Okay, now here for this these are the nothing but ratings, right? These are nothing but ratings, right? Okay, so now first check this child 0. Okay, so child 0's rating is 2. Okay, and in the left there is no other child, and in the right, so child 0's rating is smaller than C1, so we are good with just 1 candy. Okay, no issues, right? No issues here. Okay, now let's check this one. Okay, so for this one, if you see in the left, rating is 2, and in here for this child 1 rating is 4. Okay, so rating is greater than child 0, okay, from the left children. Okay, so what we are going to do, so this child rating is 1, so I'm going to add 1 to it. Okay, and we are just going to make it to 2. Okay, 1 plus 1 2, right? This is done. Now same way we have to check for right also. So in this case, this child 1 rating is smaller than child 2, so no need to change. Okay, so we are good. Okay, we change it to 2, right? Now after that, check for the next child. Okay, so next time, let's suppose my eye is here. Okay, eye is here at this particular position. So now for this child, if you see in the left side, the child rating, okay, so child rating C2 is greater than C1, right? So why he is getting just 1 candy? He should get more than the candy, more than this C1 candies, right? So C1 is getting 2 candies, so he should get more than this C1 candies, right, that he is getting. So here what I'm going to do, I'm going to change it to this, he is getting 2 plus 1, okay, 3, right? So here I'm just going to write 3. Okay, this is done. All right, now same way we have to check for this side also. So in this side, same rating, so no impact. Okay, so that's it. Okay, and you know that why I'm writing plus 1, why I'm doing -1, why I'm not directly writing 100 here. Okay, because we have to return the minimum number of candies you need to have to distribute the candies to the children. Okay, so that's why I'm taking this. Okay, just +1, I'm doing just +1. Okay, minimum value, right? So next time your eye is going to move forward. All right, okay, so let's say your eye is moving forward here. All right, so now here in this case also just check the left side. Okay, same rating, no impact. In this this rating is greater than 4. Okay, the child 3 rating, if you see, it's greater than child 4. Child 4 is getting just 1 candy, and he is getting just 1 candy. No, he should get more number of candies. So child 4 candy is just 1, so in this one add 1, so I will get write 2 here. Okay, I will write 2 here. Okay, this is done. Okay, all right, so now see carefully what is going to happen now, right? So this is done. Now next time my eye is going to move here to this position. Okay, so this one I'm going to check. Okay, now here if you see the rating of this one, okay, the rating of this one is smaller than this one. Okay, right, rating of this one is smaller than this one. Okay, so there's no impact here in one. Okay, now for the right side, if you see the rating of this C4 is greater than C2, right? So why he's getting just 1 candy and he's also getting 1 candy? So I should make it to 2, right? So now I make it to 2. All right, so now I make it to 2. Now listen carefully what is going to happen. I make it to 2. Okay, next time my eye is going to move to the next location. Okay, next position. So my eye reaches here. Okay, for this one. But here if you see this thing, okay, this child C4 having just 4 rating, he is getting 2 candies, and this child 3 having 8 rating, which is greater than this C4, which is just 4, he's also getting same. So this is wrong. So our approach is wrong here. Okay, so we can't solve this problem using this thing. Okay, so we have to think about something else, right? So in this approach we are checking, we are moving from left to right. Okay, we are moving from left to right. Okay, and for all the child, first we are checking left side and right side, and then we are making the adjustment. Then for the next child we are checking left and right, and then making the adjustment. For this we are checking left and right, then making the adjustment. Okay, but this is failing now, right? This is failing now, right? So this is not the correct answer. Okay, so now how we are going to solve this? Okay, so here just take the same example, 2 4 8 8 4 2. Okay, 2 4 8 8 4 2. Okay, so in the previous case we are checking this like this. Okay, so now what I'm going to do, I'm going to first check the I'm going to compare with only the left neighbors. Okay, and then after that, after comparing with the left neighbors, after then I'm going to compare them with the right neighbors. Okay, so I'm going to run one loop from left to right. okay, and then I'm going to run one loop from right to left. Okay, so this is, let's say this is child 0, this is child 1, this is child 2, this is child 3, child 4, and child 5. Okay, so now here first we have to give one candies to all the children, right? One, 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 one. Okay, so first we are going to check for left to right. Okay, so create one array left to right, and here just for left side. Okay, so there are no left children, so no impact. So there is one left children here. Okay, and this rating is greater than this 2. Okay, so here I'm just going to write this rating is 1, 1 plus 1, 2. All right, then this rating is greater than this, so here 2 plus 1 I'm going to write 3. Okay, then this rating it's same only, right? So no impact, so we are just going to write 1 only. And then this rating no impact, I'm going to write 1 only, and this rating no impact, 1 only. Okay, so here I'm just checking the impact from only the left neighbor, right? Then we have to check the impact from the right neighbor. Okay, so I'm going to run from a loop from R to L. Okay, so now uh, here just see this white color pencil, so there are no child here. Okay, so no impact. 4 is greater than 2, so there is one impact. Okay, so 1 plus 1, 2, and this 8 is greater than 4, so here I'm going to write 3. This 8 is similar to 8, so no impact. 4 is smaller than 8. Okay, so this is 1 only, so no impact. 2 is smaller than 4, no impact. Okay, so this is done, right? So now I'm checking the impacts from both sides, right? From left side also, from right side also. Okay, so now let's say I have to check for this particular child. Okay, from this, for this particular child. So for this particular child, if you see from L to R, just one is coming up. Okay, only one candy is coming up. Okay, if I'm checking just the left neighbors. Okay, but if I'm checking the right neighbors, then here 3 candies are coming up. So what should I choose here? Tell me, think about it. Should I choose this 1 candy for this child 3 or 3 candy for this child 3? So we should choose the max one, right? Okay, so here out of these two, what is max? Just 1. Out of these two, what is max? 2. Out of these two, what is max? 3. Out of these two, what is max? 3. Out of these two, what is max? 2. Out of these two, what is max? Just 1. Okay, so this is going to be my final output. That is nothing but 1 plus 2, 3. 3 plus 3, 6. 6 plus 3, 9. 9 plus 2, 11. 11 plus 1, 12. Right? That's it. Okay, so 12 is going to be my output. Okay, so this is actually what we need to do, right? So now let's write the code for this approach. Okay, and then I will go and show you one more approach. Okay, after this, so in this approach we are creating 2 arrays, right? Okay, so here in this case our space complexity, you can say, is going to be of 2n, right? We are using 2 arrays of n size, right? So let's write the code for this one first. Okay, so here first you need to just calculate the number of ratings we have. So int n is equal to, let me just maximize the screen, int n is equal to ratings, and then after that just calculate L to R, and same way you have to calculate R to L, and then here first we have to just assign one candidate. Okay, that is given in the problem statement. So here just I'm going to write arrays dot fill this L to R with 1. Okay, same way here you have to write arrays dot fill R to L with 1. Okay, this is done. Then after this what you need to do, first we are going to comparing with only the left neighbors. So here you have to just run one loop for int I is equal to 1, I is less than n, and here I plus plus, and then here just we are going to check if ratings, okay, ratings of I, right? Left we are checking, so if rating of I is, we are going to say if it is greater than the rating of I minus 1, right? We are checking only left side, so ratings of I minus 1, then only we have to add 1. Okay, so in this case how I'm going to update my L to R of I value. Okay, so I'm going to update it with math dot max of L to R, okay, existing value, whatever the existing value I have there, right? And from previous one we have to pick then. Okay, so here L to R, right, I minus 1 I'm going to do, and from here in this I'm just going to add 1. Okay, so this is we are checking for the left neighbors only, right? Now same way we have to move from R to L also. So just simply copy this and paste this here, and here you can say I is equal to, starting from n minus 2. Okay, and this I, it should be greater than 0, and here I minus minus. Okay, and here ratings of I, if it is greater than ratings of I plus 1, right? We are checking right ones. So here instead of L to R we have to update R to L. Okay, R to L this time, and here math dot max of R to L of I, R to L of I, and here also we have to just change R to L of I plus 1. Okay, from right side the value which is coming, and in that we have to just add 1, right? So once this is done, then after that here just we have to just return the result. Okay, so in the result we have to just count the total number of candies. So here just iterate over we have to just take the max. Okay, so int I is equal to 0, I is less than n, here I plus plus, and here you are just going to write result is equal to result plus math dot max of L to R of I, and here R to L of I. Okay, this is done. All right, so this is done. Then in the end you have to simply return result. Okay, that's it, that's it. Okay, so here simply return the result. Okay, so now let's run the code and see if there are any code issues. We'll try to fix that. So this is your approach 1 to solve this problem. All right, so let's fix the issue here. Y0 I'm writing here. Let's run it again. So there is some mistake here, so let's fix that. So we are getting some issue somewhere. So here yi less greater than 0, it should be equal to also, right? So see, all the test cases has been accepted. Now if I just write our test case, that is this 248842. Okay, let's see whether we are getting 12 as output or not. Right, this was the test case. Right, let's run it again. So see, we are getting 12, right? Okay, so now let's submit it. All right, so our solution is accepted, right? So here you see you are using two arrays, L to R and R to L. Okay, so from here also I'm choosing the max one only now. So we can actually ignore this. We can just create one array, right, instead of creating two. So that is very simple. What you need to do here, instead of creating two, just do one thing. Just change L to R. Okay, just rename it to count. Okay, count. Here just do replace all, and here just change this R to L also to count, replace all, and here just delete this. Okay, and we are already using here max only, count of I is equal to math of max of count I. Okay, this, and we are just going to update the same array here. Okay, in this also, and in the here just instead of math.max just add the count of I value. Okay, we are just updating the single array. That's it. Now let's run the code and see if there are code issues. So the test case has been accepted. Now let's submit it again. So this is also accepted, right? So now this is approach 2, right? So in this we are just using single array. Okay, in this approach I'm going to solve this problem in just O1 space complexity. Okay, so what I'm going to do here in this approach, just we are going to draw a mountain like structure. Okay, for explanation. So let's say you have values like this. Okay, here, and then there is some higher rating here. Okay, then let's suppose there is one more higher rating here. Okay, and let's suppose there is one more higher rating here. Then this is lower rating. Okay, and let's say this is more lower rating, and here there is higher rating, and then this is something like this. Okay, and let's say this is something like this, right? So this is the rating given to us, right? Okay, so here let's say this is a child 0 having a rating let's say 2. Okay, child 1 having rating 5, child 2 having rating 8. Okay, child 3 having rating let's say 12. Let's say this is child 4 having a rating here now, so you can say 7, something like that. And this is let's say child 5 having a rating you can say it 4, let's say. Okay, 4. And this C6 having 6 rating, this C7 having 6 rating, and this C8 having 6 having let's say 4 rating only, right? So now let's understand this with using this example. Okay, all right, so let's say this is ratings and this is our output. Okay, so for this particular case only, so first let's assign one candidate to all the children first. So here let me write 1, here 1, here 1, 1, 1, 1, here also 1, here also 1, here also 1. Okay, so in total how many candidates we have allocated till now? 1 2 3 4 5 6 7 8 and 9. Okay, total 9 candidates we have allocated till now. Okay, so that simply means here what is the length of this? 1 2 3 4 5 6 7 8 9. Okay, so we can say that we are going to initialize one candy variable, right? And I'm just going to set this value to n. Okay, n is nothing but 9 in our case. Okay, and after that let's start from here. Okay, so this is 0 index. Okay, 1 index, 2 index, 3 index, 4 index, 5 index, 6 index, 7 index, 8 index. Okay, so now let's start from here. Okay, I, so this, okay, this value is greater than this. Okay, child 1 rating 5 is greater than child 0 rating. All right, so there is one peak here. Okay, so this is nothing but increasing slope. right? So in this, create one variable peak. Okay, create one variable peak. Okay, so this is one mountain. Okay, so let's say this mountain starts from here and this mountain is ending here. Okay, then this another mountain starting from here, then that mountain ends here. Okay, so there is one peak in the mountain and then there is one dip in the mountain, right? So what I'm going to do here, okay, so this is one peak. Okay, create one variable peak. So here just update the peak value to 1. Okay, peak value to 1. And candies, so how many total candies we have? 9. So we are going to add one more candy here at this position. Okay, because we don't want to assign just one, we want to assign two here, right? 1 and here 2, because this rating is greater than this one, right? C1 rating is greater than C0, so we are going to assign one more candy here. So here I'm writing peak 1. Okay, I'm updating peak, okay, as 1, and I'm adding one more candy. Okay, 9 plus 1 I'm writing. Okay, I'm adding one more candy here. Okay, then next time, if when my eye is going to reach here, so now my peak is going to become 2, and I'm going to add one more candy here. Okay, I'm adding two more candies actually here. So here 1 1 1. Okay, here if I'm making 2, so here I need 3. Okay, so that simply means in 1 I'm adding 2, right? Okay, so in the candies, okay, so how many candies we have in right now? Until now we have candies 10. Okay, so now in this 10 I'm adding 2. Okay, so 10 plus 2, so now it is going to become 12 candies. 12, right? So in total, okay, first initially we have 9 candies. So here there is one peak, so I'm adding one more candy here. Okay, so let's say it is going to become 2. Okay, it was 1, so here we need bigger value. Okay, 2. So next time, this is next week. Okay, peak 2, so here next time it is going to become 3 only, not 2 plus 1, I need 3 only, right? Here, so here I'm adding 2, that's why I'm adding 2 here. So in total it is becoming 12 now. Okay, so I hope that this is clear. Then next time, this is next peak. Okay, peak 3. Okay, so in peak 3, so here how many candies? So here 1 2 3. Okay, so I'm adding 3 here. Okay, so it was 1 1 plus 3, if I'm doing, I will get 4. Okay, in total 4 candies will be there, right? So I'm adding 3, right? So here 12 plus 3, I'm going to get 15 candies right now. Okay, then done. Okay, then until here if you see, okay, peak value is 3 1 2 3, peak value is 3. Okay, peak value is 3 until here. Okay, then there is one dip. Okay, this is there is one dip starting, right? So now decreasing value. Okay, value you can say, or dip. Okay, whatever you want. All right, so now from here if you see, in previous approach, when also from the left sides there are some values coming up, from the right sides there are value coming up, we are always taking the maximum one, right? This was what we were doing in the approach one. So same thing here we also need to do now. So here first, okay, first let's suppose I'm moving, starting from here. Let's say I'm starting from here, I'm moving up. So this is peak 1. Okay, this is peak 2, right? Okay, this is peak 1, this is peak 2. So here if there is one candy, so here I'm going to place two candies. Okay, and here I'm going to place three candies, right? So if I'm starting from here, then I'm saying that here place three candies. But if I'm starting from here, then here I'm placing how many candies? Here I'm placing in total 4 candies. So out of these 4, and from here if I start, I'm saying 3. So what should I choose? I choose 4 only, the max one, right? Okay, so now here, instead of showing it like this, okay, starting from here to here, we are moving, we are just incrementing line now. So I can also show you like this. Okay, so instead of counting peak from starting from here, let's count the valley, okay, or dip. All right, so it is also going to give me the same value only, right? So here let me just reverse it, but from here you are clear with one thing, that we are now going to pick the max value. Okay, so now here what we need to do after that? Okay, so now there is a decreasing slope. Okay, and we have already covered until here. Okay, already covered until here. So until here our peak value was 3. Okay, your I is going to be here. Okay, so you see this value I. Okay, so here ratings at I. Okay, ratings at this particular index I, this one, it is smaller than the previous I. Okay, this value. Okay, rating of I minus 1. All right. Okay, now if this is the case, right, if this is the case, then what you need to do, then you have to take one more variable value. Okay, and initialize it with 0. So increment that count. Okay, so here value is going to become v1. Okay, v1, right? Next time you are going to reach here, here it is also decrementing slope, so here this is going to become v2, right? And next time your I is going to reach here. Okay, but here you see there is an increase. Okay, so there is another mountain start. Okay, peak start. But here in this case your value is 1 and 2. Okay, value is coming as 2, peak is 3, peak is 3, and value coming as 2. Okay, now here, now another mountain starts. Okay, another mountain starts here, from here, right? So now from here I already told you now what we need to pick out of these two. Okay, and side by side you can also update the candies also, right? So here candies is nothing but here you are going to add one candy, okay, and here you are going to add, so this is the current count of candies, okay, 15, right? So now you are decrementing here, okay, you are decrementing here. So in the candies, whatever the candies value, here add the v1 value, okay, one value, okay, 15 plus 1, that is nothing but 16. All right, and here after that, here when you are going to reach, so here you have to add 2, okay, 16 plus 2, you are going to get 18, okay. I will tell you why 18, okay, 18. So now it ends here, okay. So now after that, the value is coming out as 18, okay. So in this 18, okay, in this 18 we have to subtract what, we have to subtract the minimum of peak and value, okay, math dot min of peak or valley, okay. So peak or valley, what is the value that is coming out here, 18 minus math dot min of peak and valley. So peak is 3, valley is 2, so we are going to get 2 only, okay, minimum, right? So it is going to become 16, right, in the top. So in the top here 3 is coming up, okay, peak 1, peak 2 and peak 3, okay. So here we are thinking of adding 3, okay. And if I start from here I'm thinking of adding 2, okay. So right now this count has everything, okay, this candy count has everything. So that is why from here, okay, in one range we deleted the minimum one, okay, we keep the max one here, okay. So that is why I'm subtracting this math dot min peak value, okay. So this is the reason for this actually, right? Okay, this is the reason for this. All right, now after that, just let's complete this part, okay. Then after that your eye is going to reach here, okay. So here next time when my eye is here, so we are incrementing, okay. So this is a peak, okay. So we are going to initialize one variable peak and it is going to start from 0, right? And then here it is going to become 1, okay, incrementing it. And we have to add the candies also, okay. So we need one value higher, okay, of this one. So last time our candies count is 16, so it is going to become 16 plus 1, that is 17. And after that you see that there is no decrement, okay, but the same level, okay. So there is no decrement, okay. First we are going to check if it is same, then we are going to check if it is increment, and then if we are decrement, and then we have to update the candies, okay. Candies as nothing but candies, total candies right now until now we have 17, minus 17 is equal to 17 minus candies total, okay. Candies minus math dot min of peak and value, okay, math dot min of peak and value. So peak is still 1 and value is still 0 now, there is no decrement, okay, right now, okay, it is same. So here I'm just going to write 17 minus 1, so 0, it is going to become 17 only, okay. And then again we are going to start. So here there is no change, okay, there is no change because both are same only. Then after that my eye, when my eye is going to reach here, so here I will see that value count will be incremented by 1, okay. So first we have to add one candy, okay, 17 plus 1, it is going to become 18, okay. And then update, we have to update total candy size, candies minus math dot min of peak or value, okay. So peak is nothing but 0, value is 1, so minimum is 0, so 18 minus 0, 18 only. So that is what we need to return, okay. 18 is our output for this particular problem, okay. So this is what we need to do, okay. So you will get better understanding with the code, but just practice it, okay. So you can use some other examples, okay, create your own examples, dry run those examples, just practice this, okay, with your own examples. So you already know, right, why we are using this math.min pv, right? So here when we are using this slope and this slope, so we have to take the max value, okay. So we have ignored the minimum one, okay. So that is the reason why I'm subtracting this, and you already know why we are incrementing the count by 1, okay. So let's write the code is very simple for this approach also. So let me just reset this, okay. So now here first you have to just calculate the value of n is equal to ratings dot length, all right. And then take the candy is equal to n, so each person given one candy. Then after that we are going to start I from 1, and then after that we have to just run one while loop while I value is less than n, all right. And here if ratings of I, if it is equal to ratings of I minus 1, then in that case just increment the I value and we have to just continue, okay, no change, right, continue, all right. And then we have to check for the increasing slope, okay. So int peak is equal to 0 while I is less than n, and ratings of I value if it is greater than ratings of I minus 1, all right. In this case increment the peak first, all right. And then in the candies also we have to update na, candies equal to candy plus peak, okay. We need bigger values, so we are going to add one candy, okay, I plus plus, all right. Now same way we have to check for the decreasing slope also. So here you can say int valley is equal to 0, then here you can say while I is less than n, and ratings of I value, if it is less than this time, okay, then ratings of I minus 1, then in that case you have to increment the value of values, okay, value plus plus, okay. So it will give a value or peak value same, okay, we'll get same only if we go from top to bottom, bottom to top, okay. So let's use some other variable, okay, because we are just moving in one direction, right? So candy score candy plus value, and here also I plus plus, all right. And then after once this is done, then we already know that values are coming from two sides, okay, value or weak, so we have to just maintain the minimum one, okay, among them. Maximum we need to take, so we have to remove the minimum one, okay. So candy is equal to candy minus, so you can also write it like this: math dot min of peak or valley, and from here you can simply return candy. That's it, okay. So let's run the code. So in this we are not using any extra array, okay, we are not using any extra space, right? So for this problem the space complexity is going to be of 1 only, right? So let's submit it, and the time complexity is going to be of n only, right? So I hope that you guys are able to understand today's problem, all the approaches, and if you guys still have any doubts, then please ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.